Hi everybody. One of the questions that I get asked a lot these days is when should you use serverless and when should you use Kubernetes to build cloud native applications? And because of that, I've given a session about this particular topic. Now, if you're only interested in the summary, you can go to my blog. There is the summary slide as well as speaker notes right here. There's also a link to the complete deck on SlideShare. And what I want to do in this video today is to give you all the demonstrations which you won't find in the slides. In the first demonstration, I'm going to show how to develop and debug OpenWhisk functions with Node.js locally in Visual Studio Code. In order to do that, I've created a little sample that I've open sourced on GitHub. In the simplest case, you can develop functions in a single file. Like in this case, there's one main function with an input JSON with this params parameter, and some other JSON is returned here as output. To go one step further, you can develop asynchronous functions where a promise object is used. And in this case, the function is successful and the callback resolve is invoked. As you can see here at the top, you can require other NPM modules that are part of the Node.js runtime provided by OpenWhisk. If you need other dependencies, you can go ahead and create a zipped file. Let's take a look how to do that. In this case, you can use a standard package.json file and define other dependencies like the string to stream and then run an npm install. Now for the implementation, you can install or require these other dependencies in the standard way, as you can see here at the top. Now there's yet another way to develop functions with Node.js, which is Docker, but I'm going to talk about that in the second demonstration. For now, what I want to do is I want to go back to the simplest function and set a debug point, which I've already done. And now I've created a debug configuration that helps me to invoke this function. But before I do that, let me go down here and open this payload.json file, because this is where I define the input for my function. And after that, I can then click on my debug tab here and invoke my function.js. And that brings up the debugger. I can step through the code as usual, continue. And after that, I should be able to see my output here in the debug console. In this demonstration, I'm going to show how to develop and debug OpenWhisk functions locally with Docker. The advantage of using Docker is that the exact same image is used locally for development as it's used later for production. And that minimizes the risk to run into issues because of different environments. Now I'm going to demonstrate this here for Docker functions, but it works in the exact same way for other microservices that you might want to deploy to Kubernetes. So let's take a look again here at my little sample. There's this Docker folder and I have a function. Now in order to use Docker, you need to implement, for OpenWhisk, you need to implement one endpoint here, this run endpoint. I'm using the Express framework. And all I do in my implementation is to read the input JSON, this payload here from the body, and I return some other JSON. So pretty straightforward. Now, the next thing I have done is to use here this Docker file, which extends the node image from Docker Hub. And essentially all I do is to copy all of my code and my dependencies onto this image. I expose a port and I run the application. Now, in order to start the Docker container, I'm using a Docker Compose file, and I've started this container here already. In addition to that, I have implemented another utility function called run Docker function that triggers my implementation of the OpenWhisk function in my Docker container, and this is the result. So that works, but now the more interesting thing is how you can debug your code. So let's go back to the IDE. And the reason why I use a Docker Compose file here is because I open up another port, a second port, which is used for remote debugging this application. And in order to access the same code in my Docker container that is available here in my IDE, I use this Docker volume. Now what I can do is I can go in here to my function, set a debug point right here. Then I can go to my debug configuration and say function in container. So now I attach the remote debugger to my Docker container. And we can see that here right now, the debugger is now attached. Okay, so let's invoke this function again. And that brings up my debugger, and again I can, step through the code, continue, etc. Now the nice thing is that this even works when I do changes. So let's do, instead of echo, I do an echo 2 and hit Command S. Okay, and when I go back, you can see that the node runtime within my container has been restarted automatically because another tool is used here called nodemon. So when I go ahead and invoke the same function again, it brings me to my debugger with my changed code here, echo 2, and when I continue, you can see that it actually returned not echo, but echo 2 in this time. In this demonstration, I'm going to show how to do A/B testing for cloud-native applications with Kubernetes and Istio. I'm using here a sample application provided with Istio called the Book Information application, and the important parts are here in the middle column. There are a couple of different microservices, the book page service, then 3 different versions of the review service and the rating service. And as you can see here, the version 1 of the review service does not use the ratings service. However, version 2 and version 3 are using the ratings service, and there is actually one error missing right here. So let's take a look. This is the sample application, the page that displays information about one specific book, the comedy of errors. And then in the left column, we have the book details, and in the right column, the book reviews. And as you can see, I can refresh as often as I like. There are no ratings, there are no stars here showing up. The reason for that is because I'm using here a route rule that says for the review service, always use the version 1. Now, in order to change that, let's take a look at this other route rule. And here I define to use the version 2, but only for one specific user called Jason, and that is defined by a regular expression. So let's apply this rule now via the Istio CLI. Let's say, which one is it? Create version 2. Okay, so the route rule has been created. And when I go back now and I say sign in as user Jason, okay, the black stars show up right now for that particular user only. Now, in order to change that, let's switch back to the editor and let's apply another route rule. In this case, I want to define to use the version 1 and the version 3 of the review service in 50% of the cases. So let's apply this rule again. Via the Istio CLI. There we go. And now when I switch back to the browser, sign out as Jason, I see this is the version 1 without ratings. And when I refresh, it's still the version 1. When I refresh, and now we have the version 3, which has the ratings, but it's a different version because it has these red colors. Okay, in this demonstration, I'm going to show 3 different ways to deploy functions and Kubernetes applications. First, how to deploy an OpenWhisk function to the IBM Cloud. Then, how to deploy an nginx server to Kubernetes via the Kubernetes CLI. And third, how to deploy a Jenkins server to Kubernetes via Helm, which is the Kubernetes package manager. So let's start with the deployment of an OpenWhisk function. In this case, I'm using here the IBM Cloud CLI BX, and then I do an action, in this case update. I could also say create. I give it a name, person/getPerson. Function.js is the file with our source code, and then I mark it as a web function, which means that it's accessible via HTTP. So that has been done. I can now invoke this action here using the same CLI, and I pass in a parameter, and then I get a bunch of meta information right here, and at the bottom you will find the actual output of our function. Since I've marked it as a web function, I can also invoke it now by curl right here, and in this case I only get the output of the function. Now, in order to get the URL, you can use the same CLI, or you go to our web experience, and this is the function that we just deployed. This is a little editor. You can also go ahead here and change things. and you can switch to this Endpoints tab. And here's the checkbox that says make it accessible via HTTP. And at the bottom is additional information how to access this function using HTTP. You can either make it public and you can use an HTTP GET, or you can also protect it via an API key. Next, I'm going to demonstrate how to deploy an nginx server to Kubernetes via the Kubernetes CLI. So what I've done here is to create two YAML files that define my Kubernetes application, the deployment and the service. So the important part here is that I refer here to my Docker Hub image name nginx, and in the service I make sure this deployment is accessible to other services via the port 80. And then I can go ahead, switch to my CLI, and can run kubectl apply -f, which means this file deployment.yaml. Let me do that. So this deployment has been created. I do the same for the service. Service has been created as well. And now I can get a list of all nginx pods via kubectl get pods. And as you can see, there is one nginx pod running right now. Okay, and in order to try this pod now, I can do, first of all here, I need to find out the IP address of my cluster by bxcs workers. Okay, and then I need to find out the port of my nginx service, which is this one. Now what I can do is I can copy the public IP address into a browser window. Let's go back and now copy also the port. And here's my nginx server running, so that worked. And next I want to show how easy it is to scale this application. So let me go back into my deployment.yaml. And in here I simply change the number of replicas from 1 to 4. I do a Control S to save this file, go back to the CLI, and again deploy it. Apply the deployment.yaml file. There you go. And when I now do a get pods, you can see that now 4 pods are already running. The next capability I would like to demonstrate is how to deploy Jenkins to Kubernetes via Helm, which is the package manager for Kubernetes. On GitHub, you can find a curated list of Helm charts, and I can search here for Jenkins. There it is. I can open it up. And the way that every Helm chart is structured is that you have this chart.yaml file, which describes the chart. And then there's another file called values.yaml, which contains the default configuration, and you can override these settings. So when I go back to the README, right here is the documentation of these different configuration settings. For now, I just want to keep all the default values, and all I have to do is to copy this one line here, Helm install, go to my terminal window, paste it here, and execute it. And then just a couple of seconds later, you will receive some feedback that the different components have been installed, and now the different applications and pods are being launched. And there's also some documentation what you can do next, for example, how to find out the admin password and those types of things. For now, since it takes some time to load everything, I just want to invoke here kubectl get pods again to prove that these pods have actually been deployed. Okay, and there's our Jenkins pod. In this last demonstration, I want to show you a couple of monitoring tools for Kubernetes and for Istio. Now, there's a huge community around Kubernetes and lots of open source and commercial tools for monitoring, so this is really just a very small subset. Let's get started with the first tool here, the Kubernetes dashboard, which is part of Kubernetes. And the tool has a nice overview page here with CPU usage, memory usage, resource status, etc. And then a list of different object types. You can also drill down on these objects by going here to the left column and filter, let's say, by pods. And if you remember from the first demonstration, the first Kubernetes demonstration, I used here this book information sample, and here are the services. I can now go ahead and click on one of those. So this is the pod for the review service version 1, and there's lots of meta information about that service. And for me as a developer, probably the most important thing here are the logs. And in this case, the WebSphere application service used to run this microservice. Now, just one more thing I want to show here in this Kubernetes dashboard, and that's here the namespace filtering. So when I go back to the overview page again, you see only the services of the book information application. But when I change the namespace to, let's say, Istio system, there are many more or other pods. And these are the pods that the Istio runtime requires, as well as all the additional tools that I've installed. So in other words, all the monitoring tools that I'm demonstrating right now are running as Kubernetes applications themselves. So let's move over to the next tool. It's called the Istio dashboard based on Grafana. And let's just generate some more traffic here with a little script. Okay, and you should see that the number of requests will increase shortly. Here we go. Okay, so this is the overview page. There's lots of information in there, way too much to cover right now. This one I like. This is the success rate by service. So I can change here between the product page and ratings and reviews. And at this point, everything works because I'm only running this predefined sample. But there are many other diagrams that you might want to check out here. For example, the HTTP services and TCP traffic and so forth. Another tool is Zipkin, and that helps you to find out which services have been invoked and in which order. For example, I can say here, find traces for my product page application or service. And then I click on it, and I can see my product page service invoked two other services, details and reviews. And I can also click on a specific one, and then you find very detailed information about which service was invoked and which other services did the service invoke. And last but not least, as you might remember from the first sample, the rating service was invoked by two services, by reviews, the version 3, and reviews, the version 2. And as I said earlier in the static architecture diagram, one of these arrows was missing. Now, as you can see here, this is not a static diagram, but this is the real information, which is why this particular tool is so useful. These were the demonstrations that I gave in my session, when to use serverless, when to use Kubernetes. I think they showed well some of the differences between serverless platforms and Kubernetes. To find out more about serverless and Kubernetes and pros and cons, check out my blog, heitlov.net. I hope you enjoyed the video. Bye bye.